Welcome to this supplementary podcast for OblivionAgenda.com. I'm your host, Mike Adams. Now, if you haven't seen the Oblivion Agenda videos, there are many hours of lectures about this topic, and you can find them all for free at OblivionAgenda.com. Now, in this podcast, I'm going to give you additional information about the structure of spacetime and how spacetime is squeezed or bent or distorted using gravity and also gravity projection systems, that is advanced exotic technology. But I'm going to cover the basics of how the warping of space-time works and what that means for faster than light travel. Also, I use the acronym FTL, faster than light travel. And of course, when I use the letter C, I'm talking about the speed of light, which, by the way, is not a constant in the cosmos because of the distortions of space-time that we'll be discussing here. And by the way, this is all based on a presentation that I gave in Branson, Missouri on September 13th, 2019, called the Oblivion Agenda. And in that presentation, I covered some of these topics, but didn't have nearly enough time to go into the detail that they demand. So that's what this is all about, to provide additional detail. So let's start with, we're told that space is a vacuum, that there's nothing in it. Let's just say empty space. Okay, outer space, empty space, a total vacuum. But is space made of something? Is there a structure? Well, it turns out there is an underlying structure, an underlying grid that we've come to know as space-time. In other words, it's not a medium. It's not like water in the ocean or air in the atmosphere. It's something underneath that. It's the structure of space itself. And the structure might be visualized by thinking of a three-dimensional grid. So imagine a grid that's three-dimensional. So not just like an XY grid on a piece of graph paper, but one that then is 3D in that it has X, Y, and Z axes. And this grid really does describe how space-time works. So this grid, if there's nothing in space, this grid has all straight lines. It just looks like a bunch of cubes stacked together. And every angle of the cube is a 90-degree angle. This is our visualization of the grid. So I'm not saying that this is actually in outer space, just to be clear. This is a metaphor, a thought experiment to be able to visualize it. Now, what distorts this grid of space-time? It turns out that matter distorts it. So anywhere that there is mass, there is a slight distortion of this grid. The lines of the grid are bent towards mass. And by the way, that's pretty much the definition of gravity right there. It distorts space-time. And if you have a lot of mass, such as a planet or a star, then it has a very strong distortion of space-time. And a good way to understand this is to imagine an object traveling in a straight line through 3D space. Let's say it's heading, we'll just use compass directions here. It's heading north, even though obviously there's not a north in outer space. But let's just imagine we're looking at this on a tabletop, and we're going to say that the direction moving forward is north, just for a convenience sake here. So if an object is moving north on a straight line, it's going to continue to move in a straight line unless something alters its path, right? And this is an object that has a current velocity and current momentum and is not accelerating, doesn't have engines or thrusters. It's just like a rock in outer space. It's moving north at a certain speed. Well, now it encounters a planet. And a planet has a gravitational field, as it's called, but the word field is wrong. It's not an electromagnetic field of any kind. In fact, I think we shouldn't even use the word field to talk about gravity. It's kind of a misnomer. Gravity is a distortion. So it's distorting the fabric of space-time, and it's causing the grid of space-time, the three-dimensional grid, to be squeezed toward the planet in all directions, a spherical squeeze of the grid, kind of compressing the grid around the planet, but pulling that grid farther away from its adjacent imaginary cubes. And what this means is that your rock that's traveling, as we say, north through space, it's going from grid line to grid line to grid line. Now it's going to continue to follow those grid lines, but those grid lines are now being squeezed or bent towards the planet. So the object thinks that it's still going straight, and it doesn't feel any changes in its velocity vector. It doesn't feel like it's bending to the left or bending to the right, even though, let's say, if there's a planet on the left side of it and it's got this gravity, distortion effect, it's gonna pull the space rock toward the left. But again, the space rock feels like it's going straight. In fact, objects that are orbiting planets are, from their own perspective, traveling in straight lines. So the moon orbiting the Earth, the moon is traveling in a straight line relative to the moon. The reason that it's orbiting the Earth, which you would rightly say, hey, that's a circle, it's traveling in a circle, not a straight line, but it is a straight line. It's just that space-time has been distorted around the Earth into the shape of a circle, so that if you're captured in that grid and you're moving at a straight line at a certain velocity, you're actually going to traverse a circle around the planet because space-time has been distorted. Now understand that the moon doesn't have thrusters. So the moon is not staying in a circular orbit around the Earth by emitting thrust or using engines. There are not course corrections, right? The moon has no thrusters. It has no engines. So obviously the moon cannot be changing its flight path. It can't be altering its vectors. The moon is not accelerating in any direction. So how is it traveling in a circle? Again, because the space-time around planet Earth has been so distorted that the circle is what you get when you move in a straight line. Now, I know this might seem a little bit tricky to grasp. It's like, what are you saying? A straight line is a circle? Well, what I'm saying is that a straight line in normal empty space is a straight line, but a straight line in space-time that has been bent and distorted can become something that's utterly not straight. It can become curved. And in fact, it does become curved. And this is, you've heard about the slingshot effects, where we launch spaceships and then we will slingshot them around a planet or around a moon, and they can even be accelerated and their trajectory is altered. I ask you this, are those slingshotted spaceships, are they the ones that are changing their velocity vectors? No, they're relying on the gravity of the planets to do it, and the gravity is just a distortion of space-time. Now, why is this important to understand? What does this have to do with FTL travel? Well, FTL travel is, the best way to think of it is projected high-density gravity. Yeah, so an FTL drive projects a very strong space-time distortion in front of the ship if it wants the ship to go forward, and then can appear to accelerate that ship to extremely high speeds, even multiples of the speed of light, without the ship itself experiencing any apparent acceleration. This is what's crucial to understand, because if you're thinking about classic physics, you might think that, well, gosh, if we're going to take a ship and accelerate it to the speed of light, then the occupants of that ship are going to feel g-forces, right? That's what you might think. Because acceleration gives you g-forces, right? Right? That's what we've been told in classic physics. But it's not true, and here's how you can instantly know. Number one, if you're in a spaceship orbiting Earth, do you feel the pull of the Earth? No, you feel weightless. So that right there, I mean, everybody knows that astronauts that have been in outer space orbiting the Earth, there have been many orbital ships and structures over the years, since the 1970s, I suppose. And they will all tell you, no, they didn't feel gravity. In fact, they have problems from having the weightlessness. They start to lose bone density. Their heads become more spherical. They have trouble walking when they return to Earth. Why? Because they don't have gravity. They don't have the force pulling down on them while they're in their ships. They feel weightless. Well, how can they feel weightless if they're being accelerated around the Earth in a path, a curved path that should create centrifugal forces, right? But they feel nothing. They feel weightless. How can that be? Well, it's the same question of why, if you step off the top of a tall building, I don't know, maybe you're a Wall Street trader and your bet went against you and you want to end it all. So you find a tall building in New York City and you climb to the top and you step off the building. Here's the question. Will you feel gravity pulling you down and accelerating you to the street below? No, you will feel weightless. You will feel weightless. You do not feel the acceleration of gravity. You are not experiencing acceleration from your point of view. It's only an outside observer that's looking at you saying, oh yeah, that person is falling at 9.8 meters per second. Look, they're accelerating. But you don't feel the acceleration because all you're doing is traveling along the distorted space-time because you're inside the gravity distortion of planet Earth. So a faster-than-light drive system projects a very powerful gravity distortion in front of the ship, which distorts space-time, causing a very rapid apparent acceleration of the ship from an outside observer. But from inside the ship, it feels weightless. You do not feel any G-forces at all because you're still consistent with your version of how space-time, appears from where you are. When you're in a distortion of space-time, it doesn't look distorted to you. So then with enough of a distortion, ships can be accelerated, apparently accelerated to multiples of the speed of light. And the reason this is the case, why this can be done without violating the laws of physics, is because the speed of light itself changes in distortions of space-time. So the speed of light, we're told it's a constant. But of course, that's not true at all. It's a trick of the National Institute of Standards and Technology, the NIST. They've defined the speed of light by the speed at which a beam of light traverses 1 meter. And then they define 1 meter as how far light goes in a given period of time. In other words, it's a circular definition. So they've defined the speed of light by using meters, and they've defined the meter by using the speed of light. Thus, it's circular logic. This is how the speed of light is determined to be a constant. It's cheating. It's a mathematical violation. You'd get an F on that in a high school math class if you tried to prove something by citing itself. So then, well, how do we know the speed of light varies? Well, before they fixed the speed of light using this twisted definition, there were global experiments to determine the speed of light by different laboratories, and they would report in to the NIST and the US government their findings on a regular basis. And the observed speed of light from various laboratories around the world would vary quite a lot. And sometimes the laboratories, their variation would agree, as if there were cyclical changes in the speed of light. But this became so confusing to scientists, physicists and so on, that it was just agreed upon that they should just fix the speed of light, call it C, and stop trying to record the small variations, because the variations were, you don't want to have to update all your formulas every day when the actual variation is quite small. But in reality, the speed of light is variable depending on the distortion of the space-time through which it's traveling. Now, this concept is not as alien as you might suppose, because you already know that the speed of light changes when it enters glass or water. Now, wait a minute, you say. Maybe you disagree. Maybe you think you don't know that. Actually, you do. You know how when you look through a pool of water, or you look at water in the ocean, when you're standing above the water, you know how things look distorted? Like things that are deep in the water look closer to the surface than they should. Why is that? Well, the answer is because the speed of light changes as it moves from air to water. And the changes in the speed of light alter the refraction angles, creating lensing types of effects. In fact, lenses themselves are made of glass, knowing that the speed of light changes as it moves through glass. And this is why a lens is concave or convex, so that light travels faster through the thinner part of the glass and light travels more slowly through the thicker part of the glass. And it creates a lensing effect. It's just laws of physics. You also know that light, when it enters a prism, will split into its different colors, all the beautiful rainbow of light colors. Well, how is that happening? It's because it's splitting the light apart by its wavelengths, by differentiating the speeds of light as it enters this glass medium. So light does change speeds. It goes slower through some things and faster in other things. You already know this if you've ever seen water. Maybe you just didn't realize it. But what about gravity? Is light altered by gravity? Does gravity affect light? Now think about this carefully. If you emit a beam of light and it passes by a very strong gravitational distortion like a planet or a sun, does that beam of light bend just like other things might bend as they experience the distortion of space-time? Or is light immune to gravity? Does light always travel in a straight line no matter what the gravitational effect? Well, the answer, as any astronomer will tell you, or any physicist, is that gravity bends light. Why is that? Because gravity really isn't bending the light directly. Gravity is distorting the fabric of space-time, and light is traveling in a straight line through space-time. But if space-time itself gets distorted, then light appears to bend. This creates lensing effects in astronomy. So stars and planets can bend the light that's passing near them, light that's emitted from stars that, from our point of view, appear to be behind those stars or planets. In fact, this is used in astronomy to detect black holes and other things like that that have strong gravitational fields but are not necessarily visible. You can detect them by measuring the distortion of light from objects behind them. So it's a well-known effect in modern astronomy and modern physics. Yes, gravity bends light. But again, gravity itself isn't doing the work of bending light. Gravity is distorting space-time, and light is just moving at what it thinks is a straight line through space-time. So now, the reason I mention all that is because when I say that we can move faster than the speed of light, that's not technically true. When I say we can move at multiples of the speed of light, it turns out that light itself also changes speed when it enters a strong gravitational distortion. So if we are projecting a gravity field, well, again, I don't like the term field, but a gravity distortion in front of our ship, not only is our ship going to be accelerated through that distortion, or appear to be accelerated, but without feeling any acceleration, but also light itself will move faster through that distortion. So if our ship, for example, had headlights, and our ship was moving at the speed of light because it was going through a distortion of space-time, what would happen to the light emitted by the headlights on the ship? And the answer is that light would also travel at the speed of light faster than the ship. Because now we're in distorted space-time where the absolute speed of the speed of light doesn't have the same limit as in undistorted space-time. Now light can travel faster because space, you could say, is thinner. The density of the grid is thinner, much thinner, because you've projected this space-time distortion, using FTL exotic technology. So your ship is accelerating, but also everything else is accelerating, including light itself. Now your ship, you cannot exceed the speed of light inside the distortion. You can't beat the speed of light no matter what inside the field, inside the distortion. But your ship it can appear to be traveling at multiples of the speed of light, such as 10c, relative to undistorted space outside your distortion bubble. In other words, you could arrive at a planet 10 times sooner than a beam of light. You and your ship, you could arrive 10 times sooner, but the light emitted by your ship would still get there before you do, because both you and the light from your ship are inside this distortion field. But from an outside observer, it appears that you just violated the laws of physics because you went 10 times the speed of light. That's what they are seeing, because they're in undistorted space-time. So they would say that, wow, you really got there very rapidly, and that you appeared to move faster than any light that they've ever seen move. But you would say you would be able to see that light even moves faster than you inside the distortion bubble. So I know this is difficult to cover in a podcast format. This almost begs for a lot of visual displays and animations and so on. But the key to remember is that outer space has an underlying structure, and it is useful to think of it as a grid, but this grid can be altered. The grid can be distorted, and it is distorted by gravity. So everything that projects gravity, i.e. a planet, a star, even a small piece of mass, or a black hole, quasar, whatever, or some exotic technology that can project gravity, or i.e. distortions of space-time, everything can alter the grid. Every matter, every piece of mass alters the grid. The grid is malleable. And if you squeeze it enough, you can appear to travel faster than the speed of light itself. And if you squeeze it very strongly along an entire, let's say, a narrow tunnel of space-time, then you can go from point A to point B so quickly that it appears to violate the laws of physics, even though it actually doesn't. But that's what they would call a wormhole. So you've heard in science fiction, perhaps, or movies, you've heard people say, oh, well, yeah, the aliens are traveling through wormholes. And typically people imagine that there are just wormholes just randomly in outer space that are somehow connected to each other. Like you enter one wormhole and it's like a teleportation door, and you come out of another wormhole somewhere else. I don't think that's actually how it works. I think that ships are creating the wormholes as they need them, and the wormholes are then collapsing right behind them, because it takes a huge amount of energy to create a wormhole, to form it, to keep it open for, a fraction of a second so that your ship can move through it. And then that wormhole would collapse right behind you as soon as you stopped projecting the energy needed to distort space-time. So wormholes only exist for microseconds at any given location in space. And ships are using them to travel because they're creating them, and then they are abandoning them. And wormholes don't stay around because the grid of space-time wants to return to its normal, undistorted self. And that's crucial to understand. There is this natural desire for space-time to return to an undistorted state. And so it takes energy against that to distort it for a given purpose. Now, one more thing to mention in this particular podcast lecture is that when you distort space-time, such as creating a temporary wormhole because you want you and your ship to travel faster than the speed of light, when you do that, you are bending space-time to such an incredible degree that you're actually sending out ripples, like a wake, a gravity wake, that travels at the speed of light away from your event, your distortion event. So if you create a wormhole, which is really just a very strong distortion of space-time, the bending of space-time is detectable by anyone else who has a gravity meter. They would show a ripple in gravity, and this ripple would be like a wave that would travel out in a sphere around your event. So you would be sending out gravity waves that alter the speed of light and that alter the motion of objects. Gravity waves are the reason why laboratories around the Earth used to record differences in the speed of light, because Earth was being subjected to gravity waves as distant events such as perhaps wormholes, perhaps other ships out there from other technologies were traveling at 1,000 times the speed of light and sending out this massive ripple in the fabric of the cosmos. And this ripple, eventually this wave hit Earth, and we detected the ripple, or at least we saw the evidence of the ripple by measuring changes in the speed of light. These gravity waves mean that there's no such thing as stealth travel in a faster than light travel system. When you move faster than the speed of light by distorting space-time, you are sending out big waves, big gravity waves that are easily detectable by any advanced civilization. And this is a very important realization. There's no such thing as stealth travel at the speed of light or multiples of it. If you move that fast by distorting space-time, you're sending out massive signals that, hey, somebody bent space-time over here. All along this path, by the way, you'll send out a massive gravity wake along your entire travel path, the entire vector that you traveled along. It'll be a giant wake, like a motorboat going through a lake at high speed. You'll send out a very detectable pattern of gravity wakes, so to speak, that can be detected by any advanced civilization. What that means is, even in science fiction, like Star Trek, they used to pretend that if you're traveling at, warp 5 or whatever, that you were sort of undetectable at warp 5, that you were, in another dimension or something, or that you were in stealth mode. In reality, there's no stealth mode when you're traveling at multiples of the speed of light. There's no stealth. You are making big waves. And there's no way to travel at those speeds without making the waves, because you're causing ripples in space-time itself. The same way the sun causes distortions of space-time, which is why the planets orbit the sun, or the same way the Earth causes distortions, which is why the moon orbits the Earth. Your faster-than-light spaceship is creating a huge wake, and that ripple effect is moving at the speed of light. And you might say, well, which speed of light? Well, the speed of light in undistorted space-time. And by the way, there have been experiments conducted on Earth to measure the speed of the propagation of gravity waves. Because that's an interesting question, right? If there's a change in gravity, you might wonder, well, how quickly does that change traverse space? And the answer is gravity waves move at the speed of light. So you can really imagine, remember this 3D grid that we're looking at in outer space? This is a thought experiment. You can imagine the grid rippling and the ripples moving out in the shape of a sphere at the speed of light. Anytime someone messes with or distorts space-time, that's what happens. So that's good to know, that gravity propagates at the same speed as light. And gravity affects light because, well, believe it or not, all of this has to do with the unified field theory that Einstein was pursuing before his death, and other scientists have pursued. Turns out that gravity and light and space-time are all the same thing, just in different renditions. And this is why light has been so mysterious to scientists for so long. They can't figure out really how it propagates, whether it's a wave or a particle and so on. Well, gravity has been just as mysterious as well. For example, did you know that you can't block gravity? If gravity were a field, like an electromagnetic field, well, you could build like a Faraday cage and block gravity. If that were the case, you could build this cage in your house out of, some substance, some mineral that would block gravity, and then you could walk into that room and you would be weightless. That would be cool, but you can't. It doesn't work that way, because gravity is not a field. Gravity is a distortion of space-time. And that's why you can't block it, because there's nothing to block. Gravity's it's not something that's pulling on you. If it were pulling on you, you would feel yourself being pulled when you're accelerated by gravity, but you don't. If you're falling off a tall building, like I said before, you don't feel acceleration. You just feel weightless. When you're orbiting a planet, if you're an astronaut in outer space, you don't feel the pull of Earth as you're orbiting. You feel weightless. because gravity isn't pulling on you, which means gravity, by the way, has no energy itself. Gravity just distorts space-time. So in summary, I know I've covered a lot here in maybe a difficult format, but the summary here is that the speed of light is a constant when space-time is fixed or undistorted. But the moment you start distorting space-time itself, the speed of light changes. And space-time is distorted by mass, and it can also be distorted by exotic technologies that project essentially gravity simulations, or that simulate gravity. They can project very high density, or I should say high-powered distortions in the structure of space-time, which can cause ships and objects to appear to accelerate to speeds beyond the speed of light. But in reality, they feel no acceleration at all. And in reality, they're not violating the speed of light either, because the speed of light is relative to the distortion of space-time itself. So this is how extraterrestrial civilizations can travel at faster than the speed of light without violating the laws of physics. It requires a tremendous amount of energy to distort space-time, and it requires technology that we don't really have yet as Earthlings. But it is possible, and there are Earth scientists who have theoretically, or they've shown theoretically that this is possible as well. But it requires just an enormous amount of energy. And this is why FTL drives are powered by antimatter systems, because that is where you can have the most energy condensed into the smallest amount of matter that can be released in a controlled manner through things like perhaps element 115, moscovium, which I'll talk about in other podcasts. But this is how it's done. And this is why faster than light travel is probably very common in our universe. It's probably a common technology. It's as common among extraterrestrials as a Honda Civic is in America today. It's probably not even that complex, because the laws of physics support all this. You just need to be able to harness energy and deploy energy in the right way, and you too can move faster than the speed of light without violating the speed of light. Pretty cool. So yeah, instead of moving across all the space, you just bend the space. That's how it's done. So thank you for listening. You can hear more podcasts and videos as well at oblivionagenda.com. I'm Mike Adams. I publish science.news as well as space.news. I encourage you to check out both of those websites. I'm also the founder of CWC Labs. I run a laboratory. We do mass spec analysis of foods and supplements, superfoods, water, even hair, for elemental quantitation analysis, and also organic molecules such as pesticides and herbicides. You can see that at cwclabs.com. And I appreciate your support. Thank you for listening. Most of the health products and supplements that you buy at Amazon or Whole Foods or grocery stores are never tested for glyphosate, pesticides, heavy metals, or even microbiology. At our store, healthrangerstore.com, we test everything we sell. We offer the cleanest, lab-verified products sold anywhere in the world. healthrangerstore.com, over 700 products for health and home, all laboratory validated and tested for your safety. Check it out at healthrangerstore.com. Thank you for watching. If you want to support our mission, visit us at healthrangerstore.com for the world's largest selection of lab-verified superfood and nutritional products for healthy living. It's at healthrangerstore.com.